Section 1.4, perimeter and area in the coordinate plane. So a polygon is a closed plane figure formed by 3 or more line segments called sides, and each side intersects exactly 2 sides, one at each vertex. So you can name a polygon by listing the vertices in consecutive orders. So again, our vertices are again the points right here. Okay. And then we have a side. This one here again would be line segment BC, right? And this one here would be line segment CD, etc., etc. And then it's telling you name the polygon by its points, all right? So or the vertices. So the vertices are where 2 lines meet, and this one here we're calling polygon ABCDE. So we do have some certain unique names for certain polygons, but then after that we just call them by their number of sides. So, like for 3, and you should probably remember some of these, ladies and gentlemen. So 3 sides is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon. Well, that's kind of like an octopus has 8 tentacles. Same with an octagon, it has 8 sides and 8 vertices. 9 is an nonagon, 10 is a decagon, and 12 is a dodecagon. So they didn't tell you what 11 is. Well, 11 would just be an 11gon. And 13 would be a 13gon. I guess I should have put that that way. For 11 sides, that would make it a 11gon. All right. So a polygon is convex when no line that contains a side of the polygon contains a point inside that polygon. In that case, it is concave. And concave should have actually been in bold. I didn't realize that till right now. I do apologize for that. But again, concave just means it caves in. Okay, so, and we can see that from our thing here. So, from our example, excuse me. So example 1, classify each polygon by the number of sides and then state whether it is concave or convex. So just start somewhere and start labeling the sides. So here's 1, here's 2, here's 3, here's 4. So there's 4 sides. According to up above there, 4 sides is a quadrilateral, so it's got a special name. And then you're going to state whether it is concave or convex. So if you take one here and just take a vertex and go, if it goes inside the polygon here, like it does there, it just went inside the polygon here, and even right here it would go in. Just because it does that, that means that it is going to be concave. Because on one of them it caves in. All right, for B, let's go ahead and look at that one there. Let's choose a different color. So again, we're going to count the number of sides. Again, there's 1, 2, 3, 4, 5, and 6. So on that one, there are 6 sides. So a 6-sided one is called a hexagon. And again, if we go anywhere here, it will not go inside itself. So on this one here, we would say it is convex. Okay, so that's pretty straightforward, and so is finding perimeter and area. So you can use the following formulas and the distance formula to find perimeters and areas of polygons in the coordinate plane. So a triangle, remember the perimeter, which we'll just call it C. The perimeter is the area around it, so it is going to be A plus B plus C. And we did a couple of these on yesterday's homework. Not the worksheet, but the homework. All right, and remember on this here, our area is equal to base times height divided by 2. Some people like that better than 1/2 the base times height. But again, if you want to use either one, okay, it's the same thing. All right. So for the square here, again, remember it has tick marks there. So that means those are all the same length. So that would be S and S and S. All right. So the perimeter on this one here would be S plus S plus S plus S, which would just be 4S. Okay. And then the area on this one here would be S times S, or sometimes you'll see it as X raised to the second power. And then for a rectangle, again, since this one here is marked with 2 tick marks and this one here is marked with 2 tick marks, this here will be an L. Since this one here and this one here are both the same, this would be a W. So if we look at this one here, we can write the perimeter as L plus W plus L plus W. Or the easier way is to think is I'm going to combine the like terms. So that would be 2 times L plus 2 times W. And again, the area on this here is length times width, or L times W. Okay. So now we've got a couple of examples here on the next page, and then we'll be good to go. Okay. So example 2, find the perimeter of triangle PQR with vertices at -1 and 4 for P, Q is 2 and 4, and R is 2 and -1. So let's go ahead and plot those points. So -1 and up 4. So there's our P. And let's go ahead and write that as -1 and 4. And then we have Q, which is at 2 and 4. So I'm going to go over 2 and then up 1, 2, 3, 4. So there's my Q. And that's at 2 and 4. And then they told us to find R is at 2 and -1. So 2 and -1. Here is R. And that is at 2 and -1. So I just plotted the points. So let's go and look at the steps that we're going to be doing here. So step 1, draw a triangle. Instead of writing the word triangle, you can just draw a triangle. I would understand that. And we said by plotting points. And then connect the points. So I've got those there. I'm going to connect them. So here's one right there. And again, it doesn't have to be perfect here. I think when you do it on the Big Ideas platform, it will make it so it looks a little nicer than that. Because we should actually see that that would be a right triangle. Doesn't look like one, but I know it would be. Okay, so we connected the points. And then step 2. All right, find the length of each side. All right, so now remember, if it's a horizontal line or a vertical line, you could always just count them. So if we did that, we would see that's 1, there's 2, that's 3. So PQ would equal 3, but remember, according to our formula, we would use the absolute value to find the distance. So I can say 2. So remember, that's going to be x1, y1. And then I can call this one here x2, y2. So then I would have x2 minus x1, or 2 minus a negative 1, which would give us the absolute value of 3, which is 3, which is just what we just said, right? So really, if it's a horizontal line or a vertical line, start at a point and just count the number here. So QR, I'm going to say the same thing. All right, QR is going to be, if I start at Q, there's 1, 2, 3, 4, 5. And again, if I used our x2 minus x1, so again, I could call this one here now x2 and y2, and this one would be x1, y1 for the one that we're doing. And that's why I don't like to do that, because it just moves it. So that'll be what I had 2 and 4 here. And let's see. So then I had x1, y1 here. And if we did that, that'd be x2 minus x1, absolute value, which would give us the absolute value of negative 5, which is equal to 5. Okay? And then finally on the last one there, so we found this distance here, that's 5, and that one's 3, so we still need PR there. So let me see if I can get rid of stuff there without getting rid of other stuff, which I can't. So let's go back and really quickly put in that's negative 1 and 4. That's 2 and 4, and that's 2 and negative 1. So I'm okay there. All right, so now remember, and this was actually PQ. Okay, so now remember, to find PR, it's not horizontal or it's vertical, so you're going to have to use the distance formula. All right, and I'll go ahead and just write it down for you again, but remember, we did it an easier way. All right, so we know we're going to have, let's see, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So again, it wouldn't matter which one you chose to be your x1, y1 or your x2, y2. So I'm just going to do this. So like I was doing yesterday. So we have the points 2 and negative 1. And my other one is negative 1 and 4. And remember, I subtracted those. So 2 minus a negative 1. 2 minus a negative, that's positive. So 2 plus 1, that gives us a 3. And negative 1 minus 4, that gives us a negative 5. So there's our x2 minus x1 and our y2 minus y1. And then we're just going to plug that into the formula. So that'll give us 3 squared plus a negative 5 squared, which will give us the square root of 9 plus 25, which will be the square root of 34. And in this case here, let's go ahead and again, read the directions and see if it tells you to round it to the nearest tenth, hundredth, thousandth. I did this one to the nearest hundredth, so that would be approximately 5.83. On the homework, they'll kind of tell you which one to do. So this right here is 5.83. And that is what we would expect, ladies and gentlemen. All right, especially in a right triangle, the longest side is always opposite our right angle. Remember, I told you that would have been a right angle. So that's 5.83. So that makes sense. And then the final step. So step 3. Add the 3 sides. And when I do that, I'll get 3 plus 5 plus 5.83. And that will give us 13.83. Now, if they don't give you units, ladies and gentlemen, just go ahead and put units, a U, okay? That'll be good enough for me. It should be good enough on the wall side. So that is your problem right there, okay? And that's your answer, okay? Again, on the homework, make sure if they're asking you to the nearest, if they said to the nearest tenth, it would be 13.8, okay? All right, our next problem, again, we're going to kind of do the same thing. So find the area of triangle ABC with vertices at A at 1 and 3. So I'm going to go 1, 1, 2, 3. So there's A at 1 and 3. Also step 1, I'm drawing the triangle. And remember, tomorrow, when you do your homework, it'll probably be a drag and drop and it'll put it all together for you. Okay, let's see. And then what B is at 3 and negative 3. So 1, 2, 3, down 1, 2, 3. And C we have as 2 and negative 3. So negative 2, excuse me, negative 2 and negative 3. So there's C at negative 2 and negative 3. And again, we're going to connect the points there. The vertices. So we have 3 sides, which is our special name for our triangle. And now we are going to find it. So remember, step 2. The area is equal to, again, 1/2 the base times the height, or base times height divided by 2. All right. So now the base is going to be this length here. Now again, like I told you, we could just say that CB is equal to, again, if I use x2 minus x1, has to be the absolute value. Again, that was from section 1.1. So I'll have 3 minus a negative 2, absolute value, which is equal to the absolute value of 5, which is 5. Or again, you can just count from here, 1, 2, 3, 4, 5. So our base is equal to 5. All right, and now our height, okay, now I can always go on the height from the vertex A here and go straight down to the base. All right, so on that one there, again, if we think that's going to be a vertical line, so let's go ahead and call that our H, and we're going to just count. So here's 1, 2, 3, 4, 5, 6. So our height, H, is equal to 6. So then we're just going to say, so what did we just do there? We just did find the height. From point A 2, again, remember that's a line segment, CB, so I'm going to put a line segment over it. And I just told you that that is equal to 6. And now step 3, plug in. So I'll have 5 times 6, all of that divided by 2, which is 30. And remember, area is always squared. So even though they didn't give us any units, we're going to say units squared. If they were to give us centimeters, it would have been centimeters squared. Feet, feet squared, etc., etc. Remember, area is always squared. We'll see when we get to volume. Volume is always cubed. All right, that is it. I am done, and thank you.